morning, everybody. Today we are discussing the next topic of the stereochemistry, that is the symmetry element or element of symmetry. Both are same. So, an operation means in terms of group theory, if you are doing uh, some rotation or reflection, these are the some of the operation. If you are doing this operation in an organic molecule, if we get the original configuration after this operation, we will call it as element of symmetry. So there are five elements of symmetry. First is the identity. Identity is represented by the capital E, and the second operation is the proper rotation, and which is represented by the sigma, and the third operation is planar symmetry, which is represented by the sigma, and the third one is inversion center, that is represented by I, and the last one is improper axis of symmetry Sn. Let me moving into the some of the individual element of symmetry in detail. First is the identity. Identity means we know that every organic molecule are identical to itself. So that is the identity operation. So every molecule in organic chemistry have this operation, that is identity, because every molecule are identical to itself. So next element of symmetry is the proper rotation or axis of rotation. Axis of rotation means the name indicate that we are rotating the molecule through an axis, and this axis is passing through the center of the molecule, and uh, the axis of the rotation is represented by the Cn, and where n is equal to 360 divided by the angle of the rotation. So we will get a number for, we will get an integer for the n, and if it is C2, the n is equal to 2. So the 2 rotation is needed to get the original configuration. So that is the rotational axis of symmetry. And for example, consider the water molecule. The molecular formula H2O. The central metal atom is the oxygen, and the oxygen is connected to the two hydrogen atom H1 and H2. For the identification, I have to shown here H1 and H2. And one of the axis is passing through the oxygen atom, and it is represented as C2 because we are rotating 180 degree through this axis. So the angle of the rotation n is equal to 360 divided by 180, so we will get 2. So the C2 axis, if you are rotating the molecule through the axis by 180 degree rotation, we will get an indistinguishable configuration of the same molecule. So we cannot distinguish the original object and this rotated configuration. So that's why the water molecule has a C2 axis of symmetry. So next example is the ammonia. We know that the ammonia has a pyramidal structure, and the central metal atom is the nitrogen, and the three hydrogen atom is connected to the hydrogen. For the convenience, I have represented as H1, H2 and H3. And an axis is passing through the center of the atom, that is nitrogen. This is the axis is the C3, and C3 is obtained by the rotation is represented by the C, and the angle of rotation here it is 120. So that's why 360 divided by 120 we will get 3. So that is a C3 axis. And if you are rotating the molecule through 120, we will get the indistinguishable configuration of the molecule. That's why the ammonia molecule have C3 axis of rotation. So similarly, if you are rotating any molecule through a angle, if it we will get an indistinguishable configuration. So we call it as the molecule has Cn axis of rotation, and we have to represent n also. Next is the reflection operation or angle of the reflection operation or the element of symmetry. So this reflection element of symmetry means if you are cutting, if you are if the molecule is passes through a plane, this plane contain the axis of symmetry or axis of this molecule, then we will get an indistinguishable configuration. So we call it as this molecule have a reflection axis of symmetry. So consider the water molecule. The oxygen is represented by the rose ball and the hydrogen is represented by the ash balls. So if the center of the atom, that is oxygen, if a plane is passing through the oxygen, we will get the two half, and if the part is identical to each other, then we call it as this molecule have a axis reflection symmetry. And this plane, the angle of reflection is the reflection symmetry is represented by the sigma. Next is the center of symmetry. Center of symmetry is represented by I. Center of symmetry means it is a point within a molecule from which, if we draw a line to the opposite direction, we will meet similar point at exactly the same distance and direction. Consider the example, the CClFH and CFHCl. So the substituent attached to the carbon atom of both the carbon atom are the same. One is chlorine, the other is fluorine, the other one is the hydrogen. So the substituent of both the carbon atom are the same, but both the chlorine atom is in the opposite direction. So this molecule has a center of the mass which is concentrated in a one point. If you draw a line from the center of the center of the mass to any one of the atom, say for example chlorine, and we will get a distance. If we are extrapolating the same distance in the opposite direction, if we get the same atom, then we call it as the molecule have a inversion center of symmetry. So consider this is the center of a molecule. This I have shown by a point, red colored point. This is the center of the molecule. If you are drawing a line to the chlorine atom, one of the chlorine atom, we will get a distance from the center of the molecule, the red dot to that chlorine atom. If we are extrapolating the same distance in the opposite direction, we will get the same atom, chlorine atom again. So that's why this molecule has the center of the symmetry. So next is the improper axis of rotation. It is represented by Sn. Improper axis of symmetry means first we have to rotate the molecule through a Cn axis. After that we have to make a plane of the symmetry. This plane of symmetry which is perpendicular to the axis of symmetry. So then we will get a indistinguishable configuration of the object. Then we call it as the molecule has the improper axis of symmetry. Consider this molecule. This is a methane molecule. Every hydrogen atom is substituted. Every carbon atom, the one of the carbon atom is substituted by the hydrogen atom. If it is rotated by the 90 degree, we will get this configuration. And if we take a plane, this plane is perpendicular to the axis of the rotation, we will get the last configuration. And if the last configuration and the first configuration are similar, then we call it as this molecule has the improper axis of symmetry. So these are the element of symmetries. Hope you understood the concept, and you have to do every operation in a molecule. So first of all, we have to take one organic molecule in your notebook, then do this element of symmetry. Do this similar operation and find out the element of symmetry for each molecule. Okay, thank you.